Hello, everybody. In this video, we're going to do a first kind of an intro to Ansible and how Ansible is put together as software and the impact that that has on actually using Ansible. So this is our intro to Ansible lecture. Now, to do this, I was in Dubai one time and I was teaching a different class, and Kaiser was one of my students, and he said, "Hey, Prof, I'd like to do a little presentation to the class on Ansible." And I said, "Oh, sure, I'll give you 15 minutes, no problem." He said, "No, no, no, I'm thinking more like 3 hours." I said, "Okay." And he put this together. I love it, and I've used it ever since. So this is the work of Kaiser Naim, and he gave me the permission to use it, of course. But he's a great guy and a pro at this stuff. So this is his pro version of how to use Ansible. So Ansible architecture, this is mine. You've seen it before. I just want to show you that, we've got to have an Ansible server and we've got to have an Ansible client. Doesn't matter what version of Linux you're running them on. I like to use the minimal install because I'm comfortable on a command line. But if you're doing a lot of extra work with Ansible, then you might want to think about doing using a full desktop, and then you've got access to all those different tools over there. You may end up doing your Ansible configurations off the command line, but sometimes it's nice to have the extra tools. But in essence, this is all that you need. You need a server and you need a client. Now, what's going to be connected out to the internet? Well, the client, but not the server. That server is going to be housed deep inside your architecture, and maybe you can connect from it using SSH from home, but that's it. It is not for public consumption. But the machines that you're configuring with Ansible, those are, and so that's our client image. So these are some of the things that Kaiser felt was interesting to go through, and it's the real world deployments that I think are the really interesting things. So first we're going to talk about how Ansible works. Then we're going to talk about how to install Ansible, and I put that other video out there about that. You used Yum to install Ansible before. So, that's pretty much done. Then the Ansible components, how is Ansible organized? Then we get into real world deployments. Then we get into some advanced topics. And we finish out with Ansible roles. Ansible roles are just a way to scale out the complexity of Ansible and to standardize all the different uh, um, files and subdirectories that go into a more complex Ansible configuration. So what's Ansible? Ansible is all about automation, change management, provisioning, and orchestration. Okay, automation, we want to make configurations to our servers without having to visit the keyboards. And the reason why we want to automate it is because we want to make the exact same changes with a few little differences built in, things like IP addresses and host names and that kind of stuff, but to a whole class of servers. Could be two, could be 200, could be more. So, automation is a way to avoid those sausage finger mistakes that happen when we have individuals do configurations on individual servers. Change management, we want to make the changes that we need to make, but in a very organized, very structured, very auditable fashion. Provisioning, we want to make these guys available. We want to get them to our proper configuration inside our network and then deploy them by pushing them into production. And then orchestration. Orchestration is about timing, and we'll talk about that in a little bit more. So the core of Ansible is all about automation. And what Ansible does, what you do in Ansible is you run tasks. And those tasks can be things like updating a software package, creating a user, opening and closing ports, those traditional standard things that we do on individual servers. but we can do those based on conditional expressions. It says, if this thing, if we had to shut it down, then, run this. If we had to change this file, then do this. If we didn't have to change the file, then don't do this. So conditionals we can put into there also. And then we're interested in scale, not just onesies and twosies, but scale it out to a whole bunch of servers. Change management, we want to start with an existing with some sort of known system state. Known as in we know all about it, and then we want to change that system state in some sort of defined and enforced fashion. Here's an example. Maybe we want to have we want to start with a defined image that we know real well, and we want to deploy Apache Web Server version 2.4x. So one of the versions of 2.4 we want to have installed. We want to have PHP on there. We want to have that web server. We're going to transfer some files onto that guy or connect it to a file server where it will get the files that it's going to serve, and then we're going to start that web server. Why do we have to start it? Because that's the way that we get it to read its configuration files. And then we're going to use webadmin with authorized keys just to do that make that kind of configuration available. And then, if we deviate from the state, so if that's the state we want, those 4 pieces of software installed, and we check our server again and notice that it's deviated from that state, it's not at the state that we expect it to be at, then we want to change it back. We want to, redo everything by having it change back. But on the other hand, if it hasn't deviated from state, we want to check it to make sure that it's still got the same software installed on it that we expect to have it installed. And if it does, we don't want to have it do anything. And that's this idea of idempotent. And idempotent means that if you can check your servers periodically, and that periodically can be every minute, every 30 seconds, every 5 minutes, whatever is appropriate, and make sure that they're in the proper configuration, that their configuration hasn't drifted from what it should be, which is another way to say some bad guys hacked your machine. And if they are at the proper configuration, don't do anything. But if they're not, change them. And that's what Ansible allows you to do in terms of change management. Provisioning, we want to prepare a system, we want to install, update, configure software. So as an example, we want to start with a basic, kind of a golden image, a known installation of our operating system. We want to update the operating system, make sure that there's, run a yum update on it. Then we want to install a web server, we want to deploy an application, configure the application, and then start the web server. That's a pretty standard set of tasks that you would want to do around any web server that was running an application for you. So that's the whole idea of provisioning. Now, orchestration is not the same as automation. What it is, it's a way to coordinate between systems. So, for example, if we want to remove Web 1 from the load balancer, we want to run tasks on Web 1 and then add Web 1 back to the load balancer. So what we're doing is we're saying we've got a load balancer out in front of some web servers. On one of those, we want to run some tasks on it, maybe reinstall the web files that it's serving, or change something, whatever it is. But to do that, to make those changes to Web 1, we have to first remove it from the machines that are accepting incoming connections. And to do that, we need to interact with the load balancer. And so the load balancer is on a separate machine, running a separate image. And so first we interact with that separate image and pull Web 1 out of it. What that does is that stops any incoming connections from happening. Now, what we might do at that point would be to give it some time. We might say, wait 3 or 4 minutes. And in that time, what we would expect is that the existing connections to Web 1 would do their thing and log out. And then we would want to say, okay, now we don't have any connections to Web 1. Let's do the tasks that we want to Web 1. Now, when we're done with running those tasks, we want to go back to the load balancer and say, let's add Web 1 back to the pool of available servers to accept incoming connections. That's a very traditional format of changes that need to be made. But the key thing here is that first we interact with the load balancer, then we tell that load balancer, wait, do your thing, but don't include Web 1. And then it's depending on Web 1 to get back to it and say, I'm all done. I'm ready to rejoin the pool of available servers. So why Ansible? Why not Puppet, Chef, SaltStack? Uh, uh, there's some other guys out there too. Well, the neat thing about Ansible is that it's really simple and really lightweight. We don't have agents that we have to install in the machines that we want to configure. We don't have a database that we need to keep track of. It's multi-platform, but only sort of. In theory, you can do Windows with Ansible, but not many people do. Mostly it's Linux, and so most of Ansible's work is done on the Linux side of the house. We use YAML. YAML is short for yet another markup language, which the neat thing about YAML is that it's really easy to read. We'll look at we'll look at a playbook at the end of this lecture, and you'll look at it and you'll say, I kind of know what that thing does. And I always laugh in class. I say, what, are you guys geniuses that first time for you to see a playbook, you can figure out what it does? And the answer is yes, because it's written in a way with that in mind so that people can figure stuff out without reading the manual. You can just look at it and kind of get a feel for what it's doing on simpler playbooks. Of course, when they get more complex, then it's harder. But on simpler ones, it's pretty easy to see. We have built-in security. Now, where that comes from is the fact that Ansible relies on SSH. So one of the big security holes that you get with using configuration management tools is you're concerned about somebody impersonating the server that does the configurations, that interacts with the machines that are going to be configured. Well, by using SSH, we just need to make sure that Ansible server, the machine that we're configuring the clients from, is secure. And then we can, our connections between the server and the clients that we're configuring is all encrypted. And because of SSH, we've got pretty reliable security around the connection from the server to the clients. And then Ansible is very extendable, so it's built off of modules, and anybody can add a new module. And the nice thing about that is that that gives it a way to extend its lifetime, so that when things change in the future, Ansible can be modified pretty easily and extended to handle the new changes that have come its way without having to rebuild the whole thing and come up with Ansible, V 3.0 or whatever it is. So Ansible components. Well, the architecture is a client-server architecture. We have a control server, which I just call the Ansible server. And on that control server, it interacts with the clients that are out there using SSH and gathers facts from those clients. Now, what does it mean to gather facts? Well, what it means is that it asks the clients to tell the server all about how they're currently configured, what software is on them, what versions, all that kind of stuff. And then the control server knows about the clients. And if you want to find out what it tells, I may do a real quickie video, and it's just an Ansible -m setup and as an ad hoc command, and that will have your client come back with you with all of the information that it gathers from the client, and you'll find that it's pretty extensive, and we can use that text that comes back from the client is we can search through it. We can, basically grep through it and say, we can have conditionals based on it. So if the version of Linux is Red Hat, then use yum. But if the version of Linux is Ubuntu, then use apt. So, so we can do all that kind of stuff based on the facts that we gathered from the clients. That's pretty useful. Control server has 3 different components in it, and that's an inventory file, which I show you something about in the last little Ansible connectivity video I posted. It's got modules, and those modules are the way that the Ansible server interacts with the clients. We use -m ping. Ping is its own module, and there's tons of different modules out there. I think we talk about those in a little bit. And then we have playbooks, and those playbooks, or ad hoc commands, those playbooks are collections of tasks. Uh, each configuration that we do is divided up into tasks, and those tasks have a bunch of modules inside them, and that's how we divide up what we want to do. Now, on the client, all you need on the client is SSH. On the Ansible connectivity video, you saw that I really didn't go to the client much at all. I did sort of in the end, but that was just to do a few things. But you can do most everything from your server, and that's a really good thing. WinRM, that's the tool that Ansible uses to interact with Windows clients. Windows remote management, that's what that is. So inventories, I showed you one, and they're really basic to work with. You can do, Ansible gives you a default file, etc Ansible hosts, and that gives you tons of examples in there, and you can either go in and just take the examples and edit them and remove that hashtag from the beginning of the line, and then Ansible will use that as your inventory. You can do ad hoc inventories with the I switch. So ad hoc commands, you can come up with an ad hoc inventory. And then you have hosts, you have groups, and you can include variables in here also. So what you see here in the example is that we have we've got 2 different groups in there. We've got web servers and we got DB servers. And the web server group has 2 devices in it. One is 1.example.com, and the other one is alpha.example.com. And the thing with the alpha host also, it makes an IP address. So you can include IP addresses in here, or you can use host names, or whatever you want to do. And Ansible will work with whatever you give it. You can issue commands to all the servers, so you can say, Ansible -m ping all, and that will have all your servers respond. You could say Ansible -m ping web servers, if you had this inventory file, or DB servers, or one.example.com. You can do lots of things. It's very flexible with the way that it interacts with its inventory file. Modules, ships with over 500 modules. You can write your own, and you can do so things. There's modules for things like copy. There's a module for bash commands so that you can use an ad hoc command, particularly an ad hoc command, to do run some sort of bash script on your remote host, or bash commands, however you want to do that. But there's a bash module out there that you can use. There's commands for things like firewall. There's commands, firewall D. There's a module, I should say. There's a module for systemctl. There's a module for service, because some people don't want to use systemctl. The service module, in fact, calls systemctl on the remote machine, and runs a command using systemctl, but we use the service module in Ansible. I guess that's to make it easier. Module support, there's tons, and tons of stuff on GitHub, and good documentation on Ansible.com. Let's see, so -m setup, -a filter equals Ansible _eth star. So, there's yum modules, there's copy, fetch, hostname, time zone, all those kind of things are all available in modules. And we can use those modules as part of our tasks. Now, how do you install it? We've already done this, but here it is. And yum update, just to make sure that you've got all the latest versions of everything. And then install the EPAL release, and then install Ansible. Pretty easy. You want to authorize your SSH, and this is the part I forgot in the Ansible connectivity video. Yeah. I know you're all laughing, but all right, so there's that. And then we've got some ad hoc commands. So here's our Ansible web server.labxx -m ping. You'll notice in the Ansible connectivity video, I did things differently. What I did was I did Ansible -m ping and then the host name. But you can see here, Ansible does mine. It's pretty flexible in the way that it runs through its command line and parses the command line to come up with the commands that you want to use. Now, that last line, Ansible web server -m yum -a name equals vim state equals present. What are we doing there? We're installing the vim editor. But instead of saying install, what we say is, we don't tell it to install it. We just say, make sure that the state of the Vim package is that it's present. Well, to make it present, it has to install it if it's not already installed. But if you were to run this again 5 minutes later to test the idempotency in here, it would look at the state of Vim on the server and say, it's already present. So at that point, you want it to just do nothing. And in fact, that's what it'll do. And on the output from the Ansible command, you'll see that that it says change equals 0. That means that Vim was already installed, so it didn't have to do anything. So that's that. So these are our ad hoc commands. You should be working on those a little bit as we go. Oh, and you can use that ask pass to be prompted for a password. You'll notice that what I did in the little video is that I'm root on both boxes. Well, that's kind of not the way to do things. It's easier, but that's not the right way to do things. So what we should have done would be to run, uh, to not be root on either one of the machines. Maybe Ansible user or something on the server, and then an Ansible user on the client, or whatever. But at that point, you would have to use sudo to tell it to install software or to do anything that required administrative rights on it. But so at that point, you would need to think about how do we prompt for a password? How do we include a password? How do we solve the authentication issues that come up when you're working with Ansible on remote machines? So let's see. So here's our inventory. Yeah, we did that one. Uh, we talked about using the groups. In this case, we got DB servers and web servers and a bunch of different groups and stuff. And you got wildcards involved in here. There's lots of stuff that you can do. But finally, the thing that makes Ansible useful is this notion of playbooks. And our playbooks are written in YAML. Now, one word about YAML, there is something like 3 or 4 rules that you have to remember when you use Ansible. Google it, you'll find it. If you don't live up to those 3 or 4 rules, it's not going to run. But as soon as you do, life goes on. It's a lot of indentation kind of stuff, kind of like Python, and it's not hard. It's just that if your playbooks don't run, it can be very frustrating. And it could be that it's just the YAML just isn't formatted correctly, and it's got nothing to do with Ansible. It's just the YAML isn't working properly. So, pay attention to that. You Google those 3 or 4 YAML commands, and you'll be fine. So playbooks are collections of plays, and plays are collections of tasks, and tasks use a collection of modules. We do a straight ahead sequential order of execution in our playbooks. We start at the top, work our way to the bottom. Anytime there's an error, halfway through your playbook, execution stops. So, you can tell it to ignore errors, but that's probably not a good idea. And so execution usually stops when there's any sort of an error. And you can include other playbooks inside your playbook, so you can have calls to other playbooks. So here's our first example of playbook. This is the end of our video too, by the way. And you can look through this and read it. Our hosts, what hosts do we want to modify for the first play, for the first set of tasks, we want to work with the web servers. What do we want to do? In the task, well, we want to run 2 tasks. The name of the first one is install Apache web server. Hey, wait a second, that doesn't look like the normal command speak that we do, and that's because it's not. Install Apache web server, or install Apache web server or else, you big dummy, that would be fine. And what that is used for is that on the output from the running of this playbook, it will include task 1 or task install Apache web server. And so that's designed to prompt you, the operator, what you intended this play to do. And so first one, install Apache web server, we call the yum module. And in the yum module, we say name of the service that we want to install. The package we want to install is HTTPD, and that's Apache server in yum. And the state of that we want to be present. Remember, it doesn't say install. It says make it present, make it so. The HTTPD should be there. If it's not, make it so. If it is there, do nothing. That's the item potency again. The second task start Apache web server. Now in this one we use the service module, which is another way to interact with systemctl. So service, name equals HTTPD, state equals started, enabled equals yes. So, state equals started. So if HTTPD is already started, do nothing. If it's not started, start it. And then enabled equals yes. That's a way to say, if we reboot this guy, start HTTPD even without a command that says start. So when it's enabled, it's going to start every time you reboot it. Our second set of tasks, we're working on the DB servers hosts. And the first task has a name of install MariaDB server, and we're using yum for this, and name equals MariaDB -server, state equals present. And then our last task is start MariaDB server. Service module we're using for this one, name equals MariaDB server, state equals started, enabled equals yes. Anybody can read through that and figure out pretty much what's going on with this, but that's the beauty of Ansible. And I hope this helped, and we'll do some more videos about how to work with Ansible, and I'll get those out to you real soon. So take care, everybody. Bye-bye.